All right. Hello. Good afternoon, parcel people and compute comrades. My name is Will. I'm a research software engineer here at Globus Labs. And recently I've been working on Garden. I'm part of a much bigger team who will be credited at the end. But if you like the product, that's the whole team. If you don't like my takes, that's just me. So today I want to talk about some lessons we've learned from working on Garden, specifically kind of how our understanding of the problem domain we're working with has evolved while we've been working on the project. The goal of Garden, sorry, my speaker notes right there. The goal of Garden is to make it easy for researchers to share ready-to-run AI for science models on HPC clusters or the cloud. And embedded within this statement is a lot of kind of complexity and gotchas that I was not anticipating at the start of the project. And today I want to share some things that I wish me 2 years ago had known. But first, we are talking about Globus Compute today, and I want to focus on this HPC clusters bit first. So at a really, really high level, this is how Garden runs AI models on HPC clusters. We use Globus Compute multi-user endpoints. To the extent that Garden is going to be a successful project, it will be because we are successfully riding the coattails of Globus Compute MEP deployments. This allows us, for users to quote unquote, bring their own allocation to run prepackaged AI models. The Garden engineers get models deployed at facilities that have multi-user endpoints installed, specifically those deployed by admins so that it's run by root. And a consumer of these models, if the consumer is a human, they look at thegardens.ai. If the consumer is an LLM, they look at our MCP server. They get some information on models that are available at a given cluster, and they use our SDK, which is wrapping Globus Compute and Globus Auth to go invoke that model where it is deployed. And this credits their own allocation, so the Garden team isn't on the hook for managing sub-allocations or doing things that HPC admins really don't like running service accounts people get antsy about. MEP solves this for us, and I won't be talking too much about Globus Compute in this talk directly because it's just working. It's a nice, boring, reliable piece of infrastructure. And as a software engineer, boring is like the highest praise that I can give to software. We currently have this working at ALCF on the Edith testbed cluster. We are currently working on things at Purdue. Thank you, Jeffrey. And we are in talks, by we, I mean Josh and Reed, thank you, with the NCSA security team about getting this at Delta GPU. So I want to dive in a little more of what do we mean by AI for science models. For the purposes of Garden, we are not focusing on LLMs and transformers. LLMs are great. Some of my best friends are LLMs, but we are focusing more on being a robust tool library of specialized AI for science models that perhaps an LLM science agent can call upon. So here specifically, I have some chemistry and bio examples. For the purpose of this talk, I'm going to be focusing on machine learned interatomic potentials. This is a variety of model, very useful for various materials science applications. We have some cool examples of this running both on HPC and on the cloud. You can check it out. It's live at thegardens.ai use cases. What does it mean to share a model? So this is ambiguous, and there's like a couple of levels of this hierarchy here that I will explain with various Hugging Face products. The kind of like bare minimum to share a model is to have the weights and metadata available somewhere. Hugging Face Hub accomplishes this, GitHub accomplishes this. There's lots of ways to get weights shared. Second level, code for practical inference. For transformers, for LLMs, there is the Hugging Face Transformers library, there's VLLM, there's lots of useful things that make it possible to actually practically run inference. Finally, final level of sharing, have it ready to run. Hugging Face inference endpoints and like a bunch of other products and startups do this for LLMs. This gives you an idea of what it means to share. Unfortunately, most models that aren't LLMs don't have like level 2 and 3 ready and pre-made. So a lot of the complexity and difficulty in Garden is making it at least more straightforward than it would have been otherwise for users to package up this practical inference code and this sort of networking serving infrastructure for these more specialized models. What does it mean to be ready to run? Another kind of complexity here, especially as we get into the HPC world, is where are these models running, and at what kind of latency. At the top level, we're just starting to explore this. We want to be able to have Garden models deployable as co-processor model in a box for for simulation campaigns. In this case, if you have a model hot in memory, it's on the same machine, you can get away with like a pretty thin wrapper on torch.forward. If you're running something on demand, perhaps on a fast demand queue in the middle here, you can get away with, you need more, it needs to do a coherent task, but it can do like a small batch of things. Once we are actually running on HPC and behind a queue, we need to actually have much more stuff that kind of looks like application code with error handling, smart batching to make it worth the while of having waited in the queue. So this is all code that we need to bundle up. Oh, and then on the bundling up, I don't have time to talk about that. What does it mean to make it easier to share? This is worth a whole another talk, but a big question, like the gold standard we ask ourselves for someone using our product, can a researcher publish a model without handholding from research software engineers? We have this working on the cloud. We are getting this working on HPC. The stuff that we have found is the secret sauce is that users need to be able to tweak and test their model and their execution code on the hardware it's going to be deployed on. There is this dream that people have of like perfectly portable containers. We live in a fallen world and that's not possible. There's always going to be this last mile problem. Second, they have to be able to iterate quickly on the code and the environment, like the packages, together in a tight loop. When we have this, as we have found with our success, this image is like the first time an outside researcher got a model running by themselves on Garden with like no handholding from us. We were so thrilled. This is possible. So this is a summary of like big lessons I wish I had known in advance. Most non-LLM wrappers do not have production-ready inference wrappers, and making models easy to tweak and redeploy requires a tight iteration loop for co-editing runtime and inference code. Thank you. Here are some of our funders, the rest of the team, and our collaborators. Thank you for your time and your support on this project.